All right. So just kind of let you know what's going to be happening tomorrow and the first part of next week. Uh, Tomorrow when you come in, we're going to go ahead and grade the assignment. Okay, so you have the homework on this. It's going to be due tomorrow. We'll talk about it. Then for the remainder of the class, I'm going to go ahead and give you an exit ticket. So it's going to be some kind of word problem based on right triangle trigonometry, and you'll want to go ahead and use all of your whatever trig functions are necessary to go ahead and help you solve the problem. Okay. Don't forget on Monday we have our exam coming up. It's going to cover just what we discussed on trigonometry so far. So half of it's going to be real similar to the quiz you took yesterday, and you guys did really well on the quiz. Class average 72.4. Okay. So I'll be passing those back today. If you have any questions, let me know. And then next week's going to be kind of a weird week anyway because what's happening on Wednesday? We got the PSAT. Okay, so all that stuff's happening. All right, so let's go ahead and wrap these problems up. I'm going to work a few with you, and then I'm going to turn it over to Ms. Stern, and she's going to go ahead and work a few with you as well. So let's see here. This was the last one of the official notes. It says, from a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, the angle of elevation to the top of the building is 65 degrees. Find the height of the building. Okay, well, before we go ahead and start actually deciding what trig function I'm looking for, why don't we go ahead and do a quick review. Okay, we already are familiar with sine, cosine, and what's the last one? For SOHCAHTOA. Tangent, there we go. Tangent theta, okay. So what side lengths am I going to use for sine? It's what over what? Opposite over the hypotenuse. Okay. So opposite over the hypotenuse. This is not writing today. All right. What's cosine? What's his ratio? That's the adjacent over the hypotenuse. Adjacent over the hypotenuse. And tangent of theta. That was opposite over adjacent. Yes. Okay, so those you're more familiar with. Now we've been talking about these other three functions that are the reciprocals of the ones you learned back in geometry. What's the reciprocal of sine? Oh, now it would be the hypotenuse over the opposite, but what trig function? Christian? I'm sorry? Oh, you're close. Not secant, starts with a C. Cosecant, there we go. So cosecant, I'll abbreviate that CSC of theta equals the hypotenuse over the opposite. Okay, so now, Christian, what's the reciprocal of cosine? Secant. Okay, so SEC of theta is equal to, this one would be the hypotenuse over the adjacent. And we got one to go. What's the reciprocal of tangent? Oh, someone said cotangent. There we go. Cotangent of theta, he would be adjacent over the opposite. Okay, so this one ultimately wants me to figure out what the height of the building is going to be. So that represents our unknown. Now, the only angle we have is 65, right? So what is 65 with respect to, or should be x with respect to 65? Would it be? It'd be the opposite. That's exactly right. So I have the opposite side. What's 340? That would be the adjacent. Remember, the hypotenuse is always across from that 90-degree angle, and we don't know what that is. So out of all these trig functions that we just looked at, which ones use the opposite and the adjacent? Tangent and what? Tangent and cotangent. Either one of those is going to work to help us solve this problem. So I'll just go ahead and write both of them. Now remember, it's always your choice. I could say tangent of 65 degrees is equal to the opposite x over the adjacent 340. Or I could use cotangent. But remember, this time, cotangent is the reciprocal, so it would be the adjacent 340 over the opposite x. Either one of those will give you the exact same answer. Which one do we prefer to answer or solve? Yeah, the tangent one. We like to go ahead and see those where the unknown is in the numerator, because all I got to do now is just multiply through by 340. Makes it really easy. So let's say 340 times the tangent of 65. So 340. My trig button, remember, is over here by 7, right below the blue control. Okay. and it was tangent of 65. So about how tall is the building? I'd say about 729 feet. Would you guys agree? Yeah. Okay. Does anybody want me to work the other one just so you see you're going to get the same answer? You do want to see it? Okay, let's do it. So now this one over here, I would still solve the same way. I'm going to multiply both sides by the denominator. So this time you're going to have x, let me write this out again, times the cotangent of theta is equal to 340. And how would I solve for x? I should have put 65 in there. Hindsight's always 20/20. And how would I solve for x? Yeah, there you go. Just like you divide over a value, you can go ahead and divide through by your trig function. So we got about 729 feet, so 340 divided by the cotangent of 65 should be giving me the same value. So let's see here. It was 340 over the cotangent of 65. Okay. And there we go. So it does not matter. Okay. As long as you know what two sides you're working with, go ahead and choose the appropriate trig function and you're good to go. Okay. All right. Questions on that? No? Okay. Well, why don't we go ahead and take a look at this one right here. This is the first one that I gave you yesterday. Unfortunately, we are not able to get to. So your test coming up on Monday, like I said, half of it's going to look very similar to your quiz. The other half's going to have a little bit of word problems on there, and you'll see some similar to this. So it says, on a roller coaster, 375 feet of track ascend at a 55-degree angle of elevation. So remember, when you're talking about angle of elevation, that means it's going to rise from a certain perspective. Angle of depression means it's going to rotate down. Okay, to the top before the first and highest drop. First off, it says draw a diagram to represent the situation. Okay. Well, can anybody come on up and help me with that? What kind of figures are we dealing with? Right triangle, so we know we have to draw a right triangle. Okay, Rhett, you want to give it a shot? Okay. That's 55. Okay, that'll work. Okay, and I see exactly where you're going with this. So he drew his right triangle. Let me go ahead and extend that and bring this guy down. Okay. So the angle of elevation this time would be with the ground, right? So you're going to incline up. So this is my 55 degrees. The 375, that would be your hypotenuse, because that's the length of the track going up to the highest point, right? So this is absolutely right. Good. Then it says determine the height of the roller coaster. So I want to know the height of this triangle, x. Okay. And you know, this is how it typically goes. You're on the roller coaster, and then you start to go up, and you start to get closer to the top, and you're realizing, hey, you know what? I really don't want to do this. It turned out as well in the other classes when I did that, but I'm going to stick by it. I like it. Everybody can relate to it. Okay. So here's my problem. We're trying to find x. So let's see. What would x be with respect to 55? It's the opposite. 375, we already know, is the hypotenuse. So, of course, the remaining side would have to be your adjacent. So what trig functions would use an opposite and a hypotenuse? Sine. So we can not only use sine, we could also use, what's its reciprocal? Oh, not cosine. Cosecant. We could use sine or cosecant. What would you guys prefer? Sine? Okay. So now this would be sine of 55 degrees is equal to the opposite x over the hypotenuse 375. And this was a great choice, because how would I now solve? Yeah, just multiply through by that 375. Times 375 times 375. Those are going to cancel. And all I got to do is figure out the value of that expression. 375 sine of 55. So 375 trig sine 55. Okay, so we're looking at about 307 feet high. Is anybody having a hard time? Any questions? Okay. All right. Well, I have one more I'm going to work with you, and then I'll turn it over to Miss Stern. Now, this one is more similar to what you're going to see tomorrow on the exit ticket that I was referring to. So we'll come in, we'll grade the homework, any questions, and then the remainder of the period, you'll go ahead and work on this, and we'll be turning it in before you leave. Okay, so you'll probably have about a good 30 minutes to work on the problem. Now, this one says 2 ships are spotted from the top of a 156-foot lighthouse. The first ship is at a 27-degree angle of depression, and the second ship is directly behind the first at a 7-degree angle of depression. Okay, so let me give you a little bit of practice on this. Take about a minute, try to draw a diagram that you think represents what's going on here. Okay. Now, the reason this one is different, I'm going to have how many right triangles? 2. I'm going to have 2 here. I'm going to have one inscribed inside of the other. So it's almost like you're going to be solving 2 at the same time. Okay. Yes.
For this, is that 27 degrees from here to here, or from?
There you go, because when you're on the top, you're looking out your line of sight. So it'd be from your line of sight, so it would be outside of the triangle. Okay, now you might not be done with the diagram, and that's perfectly fine. But let's go ahead and kind of walk through how we would construct it. The biggest item here is, of course, the what? The lighthouse. Okay, so I would go ahead and start there. So maybe I go ahead and draw a segment. That's going to represent the lighthouse. So I know this guy's 156 feet tall. Okay. Now, of course, the lighthouse is going to be on the shore, and then going out from it's going to be the ocean. Okay. So let's say I go out so far, because remember, our ultimate goal is to create some right triangles, correct? Okay. So let's say we've got 2 ships where one is directly behind another. So just make a mark here. Let's say this represents where the first ship is, and then the end of it would be the second. Because I'm standing at the top of the lighthouse, and I'm looking down at these 2 ships. Okay. So how I'm looking down at them, that's what finishes off these triangles here. Okay. So you see how I have 2 right triangles, one inside of another? Okay, one's inscribed. Okay. Now, we've got angles here that are going to help me out. We have a 27-degree angle of depression with a 7-degree angle of depression. Now, Rhett was just asking about this. These angles will initially be outside of your triangles, because you're standing here. What you're going to be doing is not using the ground. Here, it's your line of sight. So imagine you're standing at the top of the lighthouse, and you were to look directly out over the ocean. Okay. Well, then you'd have to look down in order to see the ships, right? So the angle of depression, that means we're going to rotate down. So how far did I have to rotate down to get to the first ship? Okay, that was 27 degrees, right? So these 2 angles here would be 27 degrees. But now, because the other ship is further out, I didn't have to rotate down as much to get to it. What was it? It was 7 degrees. So this guy right here would be 7 degrees. So you see how those angles are starting outside of the triangle this time? Okay. Everybody okay with how I set it up? Did anybody happen to come up with something very similar? Okay. That's all right. That's all right. Now, let me go ahead and ask you a question, because we want to use these angles to figure out, question B, what distance the ships are from each other. Okay. So can anybody tell me What's the measure of this angle right here? Okay, this one right here where I put the red dot, this guy right here. I'm sorry? 45? No, it's not 45. We actually already have it. It's not 56. It would be 27 degrees. What would this other angle over here be? That would be 7 degrees, yes. Now here's my question. Why? You guys remember a certain idea from geometry? Okay. I'm thinking about if you have a line that intersects two or more other lines. Does that sound familiar? It starts with a T? Okay. It's a transversal. Does that name sound familiar? Okay. Well, let me go ahead and highlight it for you. Okay. So here are my two lines, the ones in blue. So we're going to go ahead and say that my line of sight and the ground going out into the water are going to be parallel to each other. So looking down, this would be my transversal. So do you guys remember hearing phrases like corresponding angles, same side interior? What would these be? The 27 and the 27. Same side. Oh, you're so close. They're not the same side. Different sides. So you can say opposite side or alternate interior. There we go. And the same reason here, this other line that's much more horizontal, again, the 7 and the 7. Is everybody okay with how I did that? Okay. So we really had all the information I needed to go ahead and set this up. Okay. But now, here's how I did it. And there are, of course, different ways. Let's say the base of the first triangle is just X. Let's say the base of the larger triangle is going to be Y. If I knew those two lengths, how does that help me answer the question? Just subtract them, okay? Because all I want to know is how far the two ships are from each other, right? Okay. So let's go ahead and set up some trig equations here. Let's go ahead and work with the smaller triangle first. What would 156 be to 27? That would be the opposite. Okay. So x would be the what? That would be the adjacent. So what trig functions would work with an opposite and an adjacent? Tangent and what? Cotangent. Now, which one would you like me to use? Tangent? Okay. So let's say tangent of 27 degrees equals, so the opposite 156 over the adjacent x. Okay. Now this one isn't like the previous one where we're going to end up just multiplying through by that denominator, but I'm still going to start it the same way. I am going to go ahead and multiply through by x because I want those guys to cancel, right? Okay. So I've got x times the tangent of 27 is equal to 156. How would I solve for x? Yeah, divide by the tangent of 150, or sorry, tangent of 27. Tangent of 27, tangent of 27. So let's see what that gives me. Let me go ahead and get rid of this. And of course, because I use the different colors, it's not going to let me use that anymore. Okay, so let me go ahead and get rid of this. Document B. Okay, so control divide, we have 156 divided by, it was the tangent of what? 27, right? Okay. So how far away from the base of the lighthouse is the first ship? Let's say about 306 feet. Okay. Now let's go ahead and do the exact same thing just for the larger triangle. Okay. And you know, if it helps you to go ahead and separate the two triangles, you know, absolutely go ahead and do that. So would 156 still be opposite the 7? Yeah, so what would the y be? Again, that would be the adjacent as well. So do you guys want to stick with tangent, or do we want to go cotangent this time? Let's go cotangent. So cotangent of 7 degrees, but now remember, tangent is opposite over adjacent, so cotangent is adjacent y over the opposite 156. So see here, I don't have that extra step where I have to divide. I'll just go ahead and multiply both sides by 156. Okay. Does that make sense? So let's see how far the second ship is from the base of the lighthouse. 156, cotangent of 7. All right, so I'm going to come back over here. 156, cotangent of 7. So it's much farther out. Oh, yes, put it in the trig, please. It's much farther out. It's about 1,271 feet if we were going to round it, right? Now, Antonio told me this a second ago. How do I now find the distance between the two ships? Yeah, all you got to do is subtract them. But I like to go ahead and use the values that are already in the calculator so I don't have to retype them. Just use your arrow key. If you highlight it and push enter, it'll go ahead and take the entire expression. Minus, okay, that. So how far apart are the ships? I'd say about 964 feet. Okay. About 964 feet apart. So this right here, that's what we were wanting. Okay. Does anybody have any questions on how I work my way through that? Okay. Are we good? Is it? Okay. All right. Well, with that, I'm going to turn it over to Miss Stern. She's going to introduce you to inverses, and I'm going to go ahead and pass out your papers.
Steal this. And so we're going to be doing the handout that you picked up at the beginning of class. That's going to be where we're going to start. And so inverse functions, they're set up the exact same way. And so it's the exact same SOHCAHTOA. But whenever we're doing it, so like with this triangle we see that our angle is right here. And so 12 is our opposite. This base is our adjacent. And then our 15.7 is our hypotenuse. And so whenever we do this, what trig function would you want to do? Like just looking at the information that we have. What do we have? And how would you set it up in like the ratio? Yeah. And so we have sine of theta equals the opposite over the hypotenuse. So we have the 12 over the 15.7. And so obviously right here we can't solve for the theta since it is in the sine. And the whole point of the inverse is literally just going to switch these two. And you don't do anything other with it. So it'll be the inverse sine of 12 over 15.7 equals theta. So you're not going to do anything to this ratio. You just move it over into the sine function, which then will become the inverse sine, and then the theta will go out on the other side. Does that make sense? You literally just move them, nothing else. Okay. And then from there, you'll plug it into your calculator. Okay, and so you go to the trig button again, and then you have the inverse sine function right there. And it's the 12 over 15.7? Yeah. Over 15.7, and you press enter like normal. And then, oh, not 157. That's different. How do you...
Oh, yeah, if,
Oh, there it is. Okay.
and then now we can just kind of arrow in. Which is point?
Yeah. Just that. There we go. That looks like an angle. Of 49.847. And then when you go back in the instructions, it did say to round to the nearest degree. And so we see that 50 degrees equals theta. So does that make sense? Because you're just going to move it over. You're not going to do anything with it, but it will turn to the inverse of sine instead of just sine. Okay. So we'll go to the next one. And it's basically the same. So we're going to look at theta right here. So what do we have? Can somebody help me label the triangle? Yeah. Yeah. And then this long side will be the hypotenuse. And then so what trig function do we want to use for this one? Yeah. And so the tangent of theta equals, 11, I'm covering up the 11 over 7. And so again, with the inverse tangent, you literally just move it to the inside, and that'll equal theta. And so from the calculator from there, you have trig, inverse tangent, and that of 11 over 7. We enter, and then that'll give us 57.5. And so that's 58 degrees once we round again, because it told us to. And so 58 degrees equals theta. So does that make sense? It's the exact same thing, just with a different trig function. All right. Nice. Okay. And then we'll go to this one. It says, the chairlift at a ski resort rises at an angle of 20.75 degrees while traveling up the side of a mountain and attains a vertical height of 1,200 feet when it reaches the top. How far does the chairlift travel up the side of the mountain? Okay. And so our diagram is already drawn for us, and we see this 20.75 as our theta down here in the corner. And then this 1,200 feet is obviously the opposite side. And then the long side that is labeled D is the hypotenuse, which will leave this base as the adjacent. And so can somebody walk me through how I would set this up? Well, first, what trig function are we going to use? Because we have the opposite, we're looking for the hypotenuse, and we have theta. Would we use cosine? We could use cosecant, yeah. Because cosine is the adjacent over the hypotenuse, and we don't have the adjacent, right? Okay, so how am I going to do cosecant? Secant 0.275 is what? Sorry. D over 1,200. Nice. And then you just multiply it across, right? To get the D by itself. And so then we have 1,200 cosecant 20.75 equals D. And then we'll go back to our calculator. 1,200 times cosecant of 20.75. That'll give us 3,387 feet. And we're gonna 87. Does that make sense? Because this time we're not using the inverse because we already have the angle. And we're looking for the hypotenuse. So you'll still set it up in the ratio. You'll just solve for the unknown variable. And then you just do the algebra to isolate it. And then you just plug it into the calculator and it'll give you your answer. Does that make sense? Anybody have any questions? Okay. Then we can go to the next one. Make that really fast. Okay, almost there. Okay. I don't know what's happening to the page.
What happened?
It started moving.
Oh.
Okay. Okay, and so the question says, a sightseer on vacation looks down into a deep canyon using binoculars. The angles of depression to the far bank and near bank of the river below are 61 and 63 degrees respectively. If the canyon is 1,250 feet deep, how wide is the river? And I'm going to give you all a minute so you can draw the diagram first. And then we can go from there. Okay. Is anybody confident in their diagram and would like to draw it? Y'all just did something like it, so I know y'all know. I don't know your name, but yours looks right. So if you want to draw it for me, that would be awesome. What is your name?
Christian.
Okay, thank you, Christian. Nice. Perfect. Thank you. Okay. And so from here, we see that we have the two different triangles. And so this first interior triangle, well, also, because the whole point of the two different triangles is you're looking at the far bank of the river and the close bank of this river. So we know that this is our little river right here. And so the first base of our triangle is going to be this little section right here, and we can just label that as X. And then the long one, we can just label as Y, and so that way we have it a distinction. And if y'all want, something that always kind of helps me is like separating the two triangles. And so we can just isolate those two. And so we'll just redo our triangle. Of just being like, this is the height, which is 1250. Our angle right here that we see is 63, and then this is X because we said that that one was X, and that's going to be our 61 degrees, and then this is our Y. And so that way you can have the two different triangles right there, and then if you want to get a little fancy, there's the river. And so we know which one the river, like which triangle the river is included in. And so based off of what we have right here. Oh, yeah, of course.
And is everybody okay to notice this problem is very similar to the one I just worked with you with the two shifts? So is everybody okay with why the base angles are 63 and 61? Does that make a little more sense? What do we call that again? It started with T? Transversal. Okay.
Nice. Okay. Yeah, of course. Based off of what we have, because we know that we have from these two reference angles, we have the opposite of 1250 on both of them, and then the adjacent on both of them is also the X and the Y. So what function am I going to use? Okay, yeah, because we can use the cotangent of 63, which is going to equal what? Yeah, because it's the adjacent over the opposite. And then from there, we'll just multiply it out. 1250 of cotangent 63 equals X. And can somebody plug that in and tell me what it is? $636.9, right? Okay. Awesome. So that's our X. And then we'll do the exact same thing for this one because it's the exact same sides, just a different angle. So we can plug in cotangent again. 61 this time equals Y over 1250. And then we multiply it out. 1250 cotangent 61 equals Y. And then what does that equal? Or what does Y equal? Yeah.
692.
All right. 692.9. equals y. Yeah. Okay. Then when we look back at the problem, like it's almost the exact as y'all did with that boat problem, right? We're looking for the river. So then we're going to have to subtract it out. And so we'll do y minus x. And so can somebody plug that in and tell me what it equals? Oh, subtraction. 55.9? Okay, and so we'll just round it up and say 56 feet. So the river is 56 feet wide. Does that make sense? Nice. It's basically exactly like that boat one. Okay. That got crazy.
Oh, wow.
I don't know. These things are too fancy for me. I think my paper touched it a little bit though, so that probably threw it off. Okay.
All right, I'll tell you what, why don't we go ahead, since there's only about 5 minutes
Yeah.
left, we won't be able to do this one, at least not right now. Let's
Okay.
at least go ahead and wrap it up and do like,
Yeah. Okay, so this side doesn't look like it, but it's just a lowercase f to correspond with that capital F, which is the angle, and so we're just solving for this entire triangle. So we're solving for angle H, and side F. So where would y'all like to start? I can start anywhere. Which one? Sorry. Okay. Side H, angle H, how am I going to do it? Okay. Okay. So you're doing cosine. And then this is the adjacent to 41. So h over 28, multiply it out like normal. And so it's 28 cosine 41.4 equals h. And so what does h equal? Okay. So 21.0. Okay, and so what do y'all want to do next? Okay, so how am I going to do it? Yeah. Okay, so how am I going to set it up? Yeah. Equals 28 squared. And so then it's f squared equals 28 squared minus 21 squared. Then we take the square root. And so then f equals, once we plug it in, yeah, 18.5. Okay, cool. And so now we are solving for angle H. So what are we going to do for that? Yeah, I heard you say like add 90 plus 41.4, and then we're going to subtract that from 180. And so 90 plus 41.4 equals 131.4. And then we know that all the angles in a triangle will add up to 180, right? And so that is 131.4. You said 48.6? 6 degrees equals h. That makes sense, right? Like you could use trig functions to find those, but also it's like, you know those properties of the triangle already, so you can just use them and do some simpler calculations. Cool.